This section is 8.2.2, which is all about complex numbers. So the first thing that we're going to do is operations with complex numbers, which is fairly simple. It's simply like just adding polynomials. So you're going to add like terms, you're going to add the real numbers and the imaginary numbers. So we have 5 plus -2, which would just be 3, and 3i plus positive 7i would just be 10i. And remember, you always want to have it in that complex number form, which is the a plus bi, or the real plus imaginary. The next one is subtraction. So same thing, you add or subtract like terms. So -6 minus 4 would be -10. And you have 13i minus a -i, which is actually 13i plus I, which is 14i. So this one is multiplication. So you can either use distributive property, FOIL, the box, whatever you like. So we have 2 times 3, which is 6, and 2 times -6i, which is -12i, 5i times 3, which is 15i, and 5i times -6i, which is -30i squared. So going back to the other video, we remember that I squared is -1, and so we never want to leave it in terms of I squared. So -30 is really -30 times -1, which is actually positive 30. So we have a positive 30 and a positive 6, which is 36. And then we'll do the imaginary part. So we have -12i plus 15i, which is positive 3i. So that's the real plus imaginary part. So we have another multiplication problem. We have 4 plus 5i and 4 minus 5i. So we're going to go ahead and, again, do the same process. So 4 times 4 is 16. 4 times -5i is -20i. 5i times 4 is 20i. And then we have 5i times -5i, which would be -25i squared. Remember, I squared is -1. So we have -25 times -1, which is positive 25. So we have positive 25 plus 16, which is a positive 41. And then the -20i plus 20i cancels out. So this is a unique thing that happens when we multiply a complex number by the opposite. So far we've noticed when we add or subtract and multiply different complex numbers, we once again get a complex number. But in this case, this is called a complex conjugate. So the complex conjugate, it's just the middle sign differs. So we have a plus bi and a minus bi. Now, if you were to add or subtract these, the imaginary part gets eliminated and you end up only having a real part. So this is definitely important to know. And the other thing that we'll talk about later on is that complex numbers will always come in pairs. So when you get a solution, you will always have something like 2 plus 3i, 2 minus 3i, because of that plus or minus part. So the last thing that we are going to talk about is the discriminant. So the discriminant is the part that is underneath the radical in the quadratic formula. It's the b squared minus 4ac. Now, when you think about the quadratic formula, that's the only part that actually tells you what type of solutions a quadratic will have. Because let's say before, if we were to get a negative number under the radical, we would automatically say no solutions. So let's say that the part underneath the radical is positive. This would mean that we have 2 real solutions. So that's kind of what we're most familiar with. And then graphically, what that means is that your graph crosses the x-axis twice. So that's just a little sketch. Now, if b squared minus 4ac, which again, the part that's underneath the square root, if that's 0, you actually only have one real solution. The reason for that is We don't really say plus or minus 0 because it doesn't matter whether we have a positive 0 or a negative 0. So one real solution means that the vertex is actually on the x-axis, okay? And I shouldn't say one real solutions. The last case is if you end up getting a negative number, then this would be, you could say, two non-real solutions or too complex. And graphically, what this would look like is the parabola would not cross the x-axis. So at this point, using the discriminant will be helpful because if I just give you a quadratic and say without solving how many solutions, you would just use this formula. So for example, if we have a quadratic x squared plus 5x plus 6, and I want to know how many solutions without solving that, I would plug it into the b squared, which would be 25. Then I would do minus 4ac, and I would end up getting 25 minus 24 equals 1. So 1 is the discriminant, so because that number is positive, that would mean, or greater than 0, that would mean it has two real solutions. So again, we did not actually solve the quadratic, we just found the discriminant. So you would find the discriminant, look at that number. If that number happened to be negative, you would say two non-real solutions. If it happened to be 0, you would say one real solution. So that is everything on complex numbers, complex conjugates, and discriminant.